hands-on program for this project. First, we are importing the CV tool, which is capture video package, for getting the input from the user, the video input from the user. Then for mathematical calculations, we are getting the math and NumPy and pandas for getting the input. Then matplotlib for plotting the graphs, images. Then Keras is an application developed by the Google, which is used for neural networks in deep learning. The first step is that we are going to get the input video and dividing the video into frames based on the seconds of the video. For example, we are giving the video for 35 seconds. After this program, we are getting 35 frames each second. We are capturing a frame. For that, we are using the CV package. We are getting the input through the video capture function of the CV2 package. Then we are assigning the frame rate sequence, which we are giving as 5, which means each second 5 frames will be there. And we are taking the 5th frame of each second and storing it as in the CV2 package using the IMWrite function. You can see the example as that this is the frame 0 and this is the frame 1, like that. It is divided into frames. Then we are going to train the model. This is done by manually by giving to each frame the class label. Which the class is that if the frame has the Jerry in it, we are assigning 1 for it, and if it is that Tom, we are assigning 2. If neither Tom nor Jerry means, we are assigning as 0. We are training this for only a certain amount of images. Then the model will be get trained in this and predicts other new frames. You can see this is the example for the frames. We are assigning for frame 1 it is 1, frame 2 class. And this class represents the Jerry or Tom, and the frame 1 represents the ID of the frames. Then we are storing the frame separately using that CV2 we are stored into the array for X. This is used to train, test, split the data. Then as we are going to use the VGGs, the pre-trained model, it accepts the image as in the shape of 224 into 224 into 3. So we need to resize the frame size. So for that we are using the resize function from the skimage.transform packages. Then we need to pre-process the input because to get the performance of the model very quick. So we are using the pre-process input function from the Keras application which was developed by the Google. Then we are going to split the data into training and testing data. Training is used to train the model and testing to evaluate the new unseen data.
Similar to this explanation, I would like to continue the next step in this building the model. First of all, in order to build a model, we need the package is known as Keras. It is an API developed by Google, and we will also use VGG tool. It is a visual geometric group. It is mainly used for conventional neural network. So, in order to build a model, we need training data and testing data. Training data is used for training a model. Building a model doesn't include only building a model. It includes building a model and computing the model, and we used to train it using the training data. In this example, as explained, we have the frames of Tom and Jerry, and we use this to train our model. The appearance of the Tom will be calculated in the class 1 as mentioned, and the appearance of Jerry will be calculated using class 2. The training data and validation is done using these methods, train and validate. First, when we ran this project, we got the accuracy around 85%. What is the drawback in this? As a Tom is a huge image, we got it is dominant over Jerry, since Jerry is a small object. So, in order to remove that, we used to reduce the domination, we consider the next row as a denser row. We try to remove the denser row, then we get the feasible results. Then after building the model, we made predictions that if any other images were included in this model, we can run this particular model. So last step, we try to calculate the screen time of Tom and Jerry. As I said earlier, since Tom is a huge object, it dominated, and as explained previously, I removed the space by removing the denser. Building the model, we used the testing file and tested this project, and we got the output. Now at last the accuracy is 86%, and the accuracy is 80%, and the validation gives 64%. So in order to calculate the screen time of a particular actor, we can use this code to calculate we have to train it using the frames. There will be inaccuracies exist when we create our own frame, because these are cartoons developed with animation. If we draw the images on our own hand, there can be inaccuracies exist. So in order to remove that, we have to develop this as animate and give it as frame. Thank you. Similar to this explanation, I would like to continue the next step in this building the model. First of all, in order to build a model, we need the package is known as CSE. It is an API developed by Google, and we will also use VGG tool. It is a visual geometric group. It is mainly used for conventional neural network. So in order to build a model, we need training data and testing data. Training data is used for training a model. Building a model doesn't include only building a model. It includes building a model and computing the model, and we used to train it using the training data. In this example, as explained, we have the frames of Tom and Jerry, and we use this to train our model. The appearance of the Tom will be calculated in the class 1 as mentioned, and the appearance of Jerry will be calculated in class 2. The training data and validation is done using these methods, train and validate. First, when we ran this project, we got the accuracy around 85%. What is the drawback in this? As a Tom is a huge image, we got it is dominating over Jerry, since Jerry is a small object. So, in order to remove that, we used to reduce the domination, we consider the next row as a denser row. We try to remove the denser row, then we get the feasible results. Then after building the model, we made predictions that if any other images were included in this model, we can run this particular model. So last step, we try to calculate the screen time of Tom and Jerry. As I said earlier, since Tom is a huge object, it dominated, and as explained previously, I removed the space by removing the denser. Building the model, we used the testing file and tested this project, and we got the output. Now at last the accuracy is 86%, and the accuracy is 80%, and the validation gives 64%. So in order to calculate the screen time of a particular actor, we can use this code to calculate we have to train it using the frames. There will be inaccuracies exist when we create our own frame, because these are cartoons developed with animation. If we draw the images on our own hand, there can be interfaces exist. So in order to remove that, we have to develop this as an anime and give it as input. Thank you.